Hello and welcome everyone to the CyVerse Focus Forum webinar series. I'm Tina Lee, CyVerse's User Engagement Officer. Today's webinar is presented by CyVerse Science Analyst Tyson Swetnam, whose presentation is on building your favorite software and environments in the VICE Workbench. Tyson's webinar is our last of the fall 2019 season, so please join us in spring 2020 for our series, which will start on the 31st of January. For those unfamiliar with CyVerse, we are an NSF-funded cyber infrastructure project, and this free webinar series is designed to fulfill part of our mission to train scientists on how to use CyVerse's computational resources. We'll quickly take care of some housekeeping, and then Tyson will get started. The presentation today is roughly 30 minutes with plenty of time for Q&A at the end. Please open and use the Zoom chat window for your questions. Materials from today's webinar, such as Tyson's slides, the documentation, for which I'll post a link in the chat in a little bit for interactive viewing, and the video recording will be posted on our events webpage for this webinar later today. CyVerse is offering our second foundational open science skills course and our third container camp. Both are scheduled for spring 2020. Please visit our website for more information on these trainings and to register. So without further ado, I'd like to introduce Tyson Swetnam, who is a research assistant professor of geoinformatics at the Bio5 Institute here at the University of Arizona. His research interests include spatial analyses in earth and life sciences using cyber infrastructure using cyber infrastructure. He also studies dendrochronology and disturbance ecology and the relationship to GIS, geomorphology, and remote sensing. He's a volunteer instructor and a lessons maintainer for the Carpentries and actively participates in the Research Bazaar Arizona group, a digital literacy group emerging at the Center of Modern Research. Hello, Tyson.
Hello, thank you, Tina. Okay, I think sounding good. We're all ready to go. So I'm excited for all of you to see this talk today about one of the newest tools that the folks here at CyVerse have created. They've done a lot of hard work to integrate this platform, and it's really exciting, and I think it's going to change the way that a lot of us do our research. So the title of today's talk is to bring your favorite software environments to the VICE Workbench, and I'll explain what VICE means in just a minute. But also point out that we will give a link to the slides. These are written in Markdown format, which are hosted on GitHub, and everything is rendered as a website. So there are hyperlinks throughout the talk that you can click on to go and explore these different facets of CyVerse and other software tools that are out there. So today's talk, I want to cover these 4 key concepts. And there's a lot of terminology that's going to be tossed around, a lot of jargon, and so we need to really focus down on what all these things mean. And so the first thing that I'm going to spend the most time talking about is our data science workbench, which we call the discovery environment. And this is a browser-based platform that you log into using your CyVerse credentials. And then from there, you can begin to do your research. You can work with your data, you can launch analyses, and then you can view and interact with your results to graphically analyze them. We'll talk about tools in the data science workbench. And essentially, a tool is a Docker container. And for those of you that haven't heard of Docker before, Docker is a software which we use to encapsulate an operating system and the different software and dependencies that those software require so that we can take that container and run it anywhere. We can run it on our laptop, we can run it on a GIS workstation or some other large local hardware, or we can run it in the cloud or on high-performance computers. So these containers are very portable, and they're an easy way to get away from the headaches of working with dependencies for those of us that have tried to work on remote platforms in the past. We have a concept which we call applications within the data science workbench. And so an application is a user interface that you use to call on a tool. There are 2 specific types of applications that we'll be spending most of today talking about. Those are executable apps, and these are things that are conventional command line calls that you run a thing using a set of flags and input and output variables, and it does the work. Or an interactive application, which is more like a browser-based or a graphic user interface, So things like the RStudio, the new Jupyter and Jupyter Labs using Jupyter Notebooks, or even remote desktops. And then last and not least is documentation. So we have documented all of these different things in the CyVerse learning materials. You can click on the links to open these and then follow our tutorials, our quick starts, and other guides on how to use these platforms. So data-intensive science. About 10 years ago, Tony Hay, Stuart Tansley, and Kristen Toll wrote a book based off of this idea that was pitched by James Gray, a computer scientist, about change in the way that we think of doing work. And this concept of data-intensive science means that we're throwing a lot of data at problems, and we're looking at the data, and the data are revealing new insights which we didn't have previously. And in order to do data-intensive science, there are three basic concepts. First, there's this concept of data capture. So you have to go out and get these big data and bring them somewhere so that you can work with them. After you've captured the data, you have to curate the data. So they need to have metadata, which goes along with them so that they are indexed and searchable, and that you can actually do things with this big mountain of information, which by itself is just really tedious to take care of. And then last is this actual analysis step. And so part of what I'll be focusing on today is more of the analysis part of data-intensive science. CyVerse is here to help you in the capture and curation of those, but really what we want to get at with this VICE environment, this visual interactive computing environment, is the analysis component. And so really what we want is to have our cake first. And so what this little animation is going to show is using the data science workbench to launch an interactive application in CyVerse. And it's as simple as logging in, searching for the app, and then launching it. And once the app is launched, it becomes available to you, and you can drop into it in a new browser tab and begin to do your science. And so these tools that we've provided for you, they have a couple of fundamental things. So our data store is built from a platform called iRods, the Integrated Rule-Oriented Decision System, and it allows us to mount a file system where you can see all of your data. We've added these widgets to this Jupyter Lab instance, which we're looking at. So we have GitHub and Git, we have Python, we have R, we have the Julia kernel and the Bash kernel, all available so you can open these notebooks up and begin doing your work right away. And this interface it's graphical, it's fairly simple to look at and use. It's something that your students can use without having to know how to use the command line. And once you're in it, you're working with your data, and this is operating on our infrastructure. So it's large cloud-based computing with connections out to other places. And so that's our cake. That's what we want to get to in the end. And so some of you have probably already worked with these remote notebooks on cloud. You've heard of things like the My Binder project, which is a way of taking a container and launching it on a cloud service. There's the Google Colab, which is similar, launching Jupyter Notebooks on the Google Cloud platform, and the Microsoft Azure Notebooks, which run on the Microsoft Cloud service. And so these are great. You can go and at the click of a single button, be into a Jupyter Notebook type interface and be doing work, or even an RStudio Notebook interface and doing work. But there's a few caveats to that. So in order to run a binder, you have to have hardware. And those binders are typically being launched on a service like the Google Cloud platform or on the Microsoft Azure. And so those are hosted, someone's paying for those. The size of those virtual machines that you're allowed to launch are very small, typically a single core, 2 cores at a time. They're very limited in their processing ability to do actual data-intensive science. They're time limited, so you can launch these and run them for 12 to 24 hours, and after that amount of time, they're going to expire. Some of these applications, if you leave them alone for more than 10 minutes, they'll time out and they'll stop, and any work that you've done in there will disappear. And then they're access limited in the sense that these providers have not opened up their virtual machine to allow you to connect over a whole range of IP address ports. They're limited in what they're able to do. Whereas when you launch these in Vice, we have a little bit more freedom and flexibility. The benefit to working with something like Colab or Azure Notebooks is that they are natively integrated into these cloud providers. So you can easily scale from a very small VM to a very large VM to hundreds of virtual machines working in a distributed environment. You have access to all of the GPUs, the tensor processing units that these services provide. However, these are not free. So you need to have a credit card available so that you can access these larger platforms. So if your research grant has money in it for using cloud services, or you have credits on these platforms, then you can go and you can work there. The benefit to working in our CyVerse visual interactive computing environment, or more simply thinking of as interactive apps, are that we run on an Internet 2 backbone. So we're situated at the University of Arizona. We have platforms that run at the Texas Advanced Computing Center. And so our networks are some of the fastest networks that are available in the United States. You have access to our multi-petabyte data store. So users that bring their data into CyVerse, we have a soft limit of 100 gigabytes, which can be increased up to 10 terabytes with a short request that you send to our science team and we review it. You can go much larger than that if you're willing to provide some more source funding for that. So we have users that have tens to hundreds of terabytes of data in our data store. They're able to access those data by running in our interactive apps. CyVerse offers privacy, security, and shareability. We have an OAuth 2 system so that you create a CyVerse username. Your apps that you create are private. They're specific to your user. You can create a team or a community with your fellow members and share that private app just with those members. If you would like to publish an app with us, you can do that as well. But those containers, once they're built, they're private to our system until the time comes that you would like to share them. But you can share them just amongst your team members if that's what you would like. We're also connected within the NSF supercomputer framework, the Exceed platform, which are multiple different HPC systems, high throughput systems, HTC systems, which are spread across the United States. So you can launch an app and then send your distributed jobs out to the Exceed. Similarly, we're part of the Open Science Grid, which is a high throughput computing platform. So you can send jobs from the data science workbench to the Open Science Grid to launch thousands or millions of jobs at a time. And we're free to use to NSF supported researchers. Those of you that are in the United States can sign up for a free CyVerse account today and use our platform. We have several featured tools that I'll have time to go over in today's webinar. The platform is extendable to almost anything that can be containerized, but the focus for our data science today, we're mostly thinking about working in Jupyter, looking at Jupyter Notebooks, working in the Jupyter Lab. There is the RStudio, which is a user interface for the R language. We're using containers which were created by the Rocker project, and we're very grateful to all the work that they've done to build these containers. So we have a suite of RStudio available, the RStudio Base, the RStudio Tidyverse, and even some RStudio geospatial applications. So you can come and you can launch those base containers in our platform. We also have remote desktops, which you're able to launch using the XPRA client. This is an X11 rootless-based platform that will run a Linux-based desktop in your browser. Any type of platform which is using WebGL or HTML5 can also be integrated. And so if you have a desktop application which you'd like to containerize, we can bring that into our Workbench and you can have that available. Okay, so I mentioned that there's a lot of jargon. There are a couple of terms that I want to go over to help familiarize you with the discovery environment so that when I do the live demo, you don't become lost. So this concept of a tool, which is essentially a container. A container can have two different forms. It can be a specific application that does a single thing. So a very small and lightweight container which contains a single type of application for doing a single type of job. And this could be something that's non-interactive, it's executable. And so this would be something that you use on the command line, which says to invoke this thing have an input file or an input directory, an output file or an output directory, and a set of variables, flags, or parameters which are required to do that thing. And so that type of container is very simple. We can also have a container which is very complex. It can have a whole suite of applications which are built into it, and each of those applications is called at a different time and does a different thing. That could be a virtual desktop which has many different scientific tools built into it so you can interact with it. We have tools which are designed to run on high throughput computing, and so I've already mentioned the Open Science Grid. You can have a tool which runs in our environment but is sending those hundreds to thousands to millions of jobs out to a high throughput computing grid, doing that work, and then bringing your results back into our data store. And then last, which is the focus of today's talk, are these graphic interactive, graphic user interface or interactive apps. And so you have a Docker container which has something like Jupyter Lab, RStudio, RShiny, or a remote desktop built into it, and then you can integrate that Docker container. Okay, the second part of this is the app or the application. And an application is a graphic user interface which you build in the discovery environment for starting that container. And so the app is just a basic user interface which you design. It can be set up to start that command line process. So instead of a user having to type in the file name and the folder name and the variables and the flags, you can create a UI and set those up so that they just have to click buttons and they can start that application. Similarly, with the Open Science Grid apps, you create a user interface for those, or the interactive apps, which you create a launch button and they can launch that desktop and begin doing their work. Okay, so when you log into the discovery environment, this is what it looks like. I have a screenshot of it there on the left. And there are these three large square buttons on one side. One of them says data, and this is our iRods data store, which is essentially a cloud data storage service. It mounts your data and makes them look like they're in a folder directory, which you can access. You can also share those data with other users, and you can view other data which are shared with you. There are data which are in community folders, which you can access, and you can bring those data into your apps when you run them. The second square there, the apps button, this is where you can find an app which has been integrated into the Workbench and you can start it. Or you can also manage a tool by adding it and then creating an app and editing it. So there's multiple features in there, and I'll show that in the live demo. The last button there on the bottom is the analyses button. And so if you do launch an analysis, you'll see that it's there and it's running, and you can access it that way. In the upper right, you see there are three other buttons. There's a notifications button, which is the bell. At this time, I had 3 notifications when I took the screenshot. There's your user profile, which you can go in and you can edit, and then there's an information button. In the lower right, you'll see that there's a little bubble, and that is our intercom system. That's for chat. So we have some user support. If you have questions, you can type a message to us, and if it's during standard business hours, during the week, someone can usually answer that within about 15 minutes. If it's late at night, or if it's on a weekend, then you can expect an answer probably on Monday or after whatever the holiday is. We have a workflow, which we think of when we're integrating our first tool. So if you wanted to bring your own app and tool into the discovery environment, the way that this works in the visual interactive computing environment is that we are using official registry images from the Docker Hub. So we're taking images which are certified by Docker. We don't want to take images from users which we cannot see the contents of, so we don't want any malicious software being run on our platform. So we select these official registry images, and then because CyVerse has some special things in it, like the iRods data store, we can add in those software to those containers and make them ready to run in our visual interactive computing environment. And so what that means is there's a Docker file, which is the recipe file, which is required to build a Docker container. We've written that and we've hosted that both in GitHub using continuous integration to make sure that things don't break down. And then we host that container on the Docker Hub so that we can pull it into our Workbench when it's ready to run. And so if you wanted to come and run an application in the Workbench today, you can come and find an app which is ready to use, and you can start and run it. If that particular app doesn't have your tool in it or your software that you want to use, you have a choice of taking our ready app, bringing it into your own GitHub repository, and installing your software. You can then build your Docker container, and then you can integrate your own container into the discovery environment. And so in this step, we're trying to take most of the work out for you so that you can start your work. Oftentimes, installing software, it doesn't take very long, so you should be able to use a ready app, and you can use the Conda environments, which are set up in the Jupyter Labs for doing that. If you install or run an RStudio program, you can install your R packages. But if there's any sort of Linux dependency, then you would need to either contact us about adding it to our official apps, or you would need to build your own. And so the way that you integrate your own Docker containers is that you open the apps window, and then you see in the upper right there's a Manage Tools dropdown, and then you ask to add a tool. And when you open that Add a Tool window, you'd see something like this. This is a tool which already exists, which is why it says Edit. The tool has a name, which you specify. This is specific to the data science workbench. This is separate from the actual container, which lives on the Docker Hub. But you can give it a name, you can give it a description, and you can give it a version, which is equivalent to the tag number, which you would see in a Docker container. You can then select what type of app it is. And we have those 3 different types of app, as you recall. We have executable apps, we have open science grid apps, and we have interactive apps. And so you can select the type of application. Here I'm integrating a Jupyter Lab, which is an interactive type of app. And then once I scroll down a little bit, you'll see that I have to give the location of the container on a Docker registry. This particular container is coming from the official Docker registry. And so you see I only need to give my organization name, and then the name of the container, and then the container also has a tag name. And so this is a convention which is used by Docker for those of you that are familiar with it. If you want to use a container from a registry other than Docker Hub, you can give the URL here. You would then need to give the name of the registry, the name of the organization, and the name of the container there, along with the tag. Another couple of set of important points are that your container needs to have a specified entry point, which means that when it starts, it needs to know what it's doing. Normally, when you start a Docker container from the command line, you're saying Docker run this container, and then you give it an entry point, like run this app or run this platform. And so if your Docker file doesn't have that specified, there's no other way for the discovery environment to know what it needs to do. So you can set the entry point in the tool here. If you've already set it in the Docker file, you can leave that field blank. Similarly, you need to set the working directory. So if the container has to run in a specific place, you should set that. In this example, I'm just setting the home directory to the Jovian username, which is the default username in a Jupyter container. And I'm creating a new folder called work so that it goes there. And I have to set the user ID number to this 1000 group name. The last part here is if the container runs on an open port over an IP address, that you need to add this here. So some applications don't require this. The executable applications typically don't. For those of us that have used Jupyter, you know that the default port number is 8888. For those of you that use RStudio, you know it's 8787. And so you just need to set that there. And once you've done that, then the tool will be complete and you'll be ready to add your app. Okay, so at this point, we're going to take a few minutes to do a live demo working in the discovery environment, and then we'll come back and take some questions. Okay, so you can see I've been running this talk in my browser. This is a link to the Learning Center pages if you're interested for looking at more information there. But here is my discovery environment. You know, I'm actually going to log out of this so that I can log back in. Let's see if I can just exit. Okay, so when you arrive at the CyVerse landing page, it should look something like this. So it says, this is the de.cyverse.org URL, and you can log in here, and it takes us to our OAuth 2. I'm logging in. The discovery environment's loading. You can see there the intercom button. Okay, I'm going to close these windows for a second just so we don't see them. You can see that the intercom button is here. It opens up. You can close it down. Okay, thank you. Again, the interface. So the 3 buttons, the data, the apps, and the analyses. The data window looks like a folder system. I can go and I can view my personal files that I've added. I can view public data, which are in the community folder, or I can view these data which have been shared with me. And excuse me, I've increased the font size to an extreme level here, so it's a little hard for me to navigate things. Let's see if I can make that a little smaller. Okay, so I'm going to close that for now. Okay, so the apps window, if it's open, you'll actually see it here in the bottom. If I click on this, it opens here. And so in the apps interface, there's a few different features here. There's categories, so you can organize your apps. There are apps which have been integrated by topic using the EDM ontology. You can build workflows or run things on HPC platforms. But for right now, I'm just going to look at my apps. And I'm going to look at my private apps, which are under development. So these are different apps which I've already integrated. If I click on one of these, it opens up the app window. We can see that there's an analysis name. It gives it a default username. You can edit that. You can set a comment, and you can set where the data will be stored after the analysis completes. You can see that there's an add data feature, which is not required. I can add a single file. I can add multiple files, or I can add a folder. When I start the app, I can leave these blank because I can also add data after the app is running. I can also set the minimum requirements for what this app needs to run. And if I press that launch button, it would launch that app and we would be on our way. But what I want to show you guys this morning is how to manage a tool and how to add your own tools. And so by clicking on the Manage Tools button, you can see this window opens up. These are different apps which have been integrated and are public. If I look at only my tools, I'll see all of the apps that I've integrated that are currently private. So these are apps that are either shared with me or apps that have not been published yet. And if I click on the Add Tools button, I can see this new field where it asks me to add the tool name. So I'll say Jupyter Focus Forum. This is just a test. Go to the version. I'm going to use the same version of the container I want to use. And I'll say type. So you can see here I have executable apps, interactive apps, and open science grid apps. I'm going to integrate a Jupyter app right now. And so now I have to select a container name. In the CyVerse GitHub, we have set up a series of Jupyter Lab, RStudio, Shiny instances. Each of these are hosted on the Docker Hub. And so I can click on one of these. I see a README page with a set of things about, these are called badges. These are linked to the Docker Hub directly or back to Circle CI. So I can go to Docker Hub, see that this image is here, and see that it's on that community name and tag. But really what I need to do here is just copy the URL. And I can copy it here. And so now I have the Docker Hub URL, I have the organization name and the container name. And this particular app has a few different tags in it. So I can look at the tags. I'm going to want to integrate this version 1.0.9. This is important, so I'm going to use the 1.0.9 tag name. And then as you saw before, you have to set an entry point. This particular container should have an entry point already set. So because it has an entry point set, I'm going to leave that field blank. I'm going to use the home Jovian work folder. I'm going to set this UID to 1000 so that it has access to it. Okay, the ports field you can see right now is closed, but I'll open that up. And then I'll add the port number. And I'll save it. So I've just created that new app and it shows up right here. So this is a private tool, which belongs to me. You can see the information for this tool. There are no apps that are yet using this tool. So I've just integrated my first tool. Now I need to create an app for that tool. So by clicking on the Create App field, I see a new interface that says New App. I'm going to look for that. And I can use the search feature here so that just by typing in Focus Forum Webinar, it comes up. I'll give it a name. Just call it that, test. And then I can add in information. So in this first section, I want to add in an input file, multiple input files, or input folders. And so now I have 3 different things which are built into this section, which I can rename input data. And you see that's updated there. I can add a new section. We'll call it output data. And we'll give it an output name, an output folder name, multiple output folder name. Okay, so now I can save this app. The app has been saved. I'll close the window. And then if I look for it here, let's see, it didn't come up. It's called Jupyter Test. And so I can see that it's locked, it's private, only to me. If I click on that button, we now see those input data, output data folders I've asked for. And if I press the launch button, it would launch, but I'm already running 2 apps. So in the sake of time, I've already gone ahead and launched the Jupyter Lab. So I started this right before the forum began. And so in the analyses field, I can see that I have 2 running apps. I have a Jupyter Lab. So I'll close it here and we'll just reopen both of these. So I click on this button. It opens a new tab in my browser. There's the location of this app where it's running. And so here I am in the Jupyter Lab. I have 4 different types of notebook I can launch. I can run a Python 3, a Bash, Julia, or R kernel currently. This has integration with Docker Hub. So, with GitHub. So if I go, let's try this. Sorry, oh, that's not my GitHub username. This is actually reading directly from GitHub. And so I should be able to view the GitHub page that I've developed there. We have integration with an iRods widget for our data store. So this is connected to my data store account. And so these are the folders in my data store that I can access. I can also come in on the command line. Let's see if I can do this again. So if I use the I command ILS and I give it my password, it will list the contents of my CyVerse directory. So this is where I can begin to bring data into my workbook and do work. So I'll just point out one more thing. I have XProd desktop running here. This is running a GIS program called QGIS. And so this is the UI for this. So this is, again, a remote desktop running my browser. It has pretty good refresh rates. I'll close that for a second. This is the tabs for opening different apps in this remote desktop. This desktop is very, it's very basic. It only has a couple of things in it. So I type in the ILS command, and again, I can see the contents of my data store, and I can use iRods to move data into this container and run things. Okay, so I'm going to conclude my live demo right there. I just want to acknowledge that these images are available online. I've pulled them directly from their host source organizations. All of the links are available in the code here on GitHub. So if you want to go visit those or look at that on the Markdown side, you can do that. And last, I want to thank the National Science Foundation for funding CyVerse. We've been funded under 3 different awards. Current award there is listed last. And our partners at the Texas Advanced Computing Center and Cold Spring Harbor. Okay, thank you very much. I'm going to look up now and see what questions have been asked.
Thanks, Tyson. Yes, there's a bunch of questions, and thankfully some of our community members have been able to weigh in. But for the record, for the video recording, I'd like to read some of the questions in, if that's okay.
Okay.
So someone had a question about the ability to increase your storage on the data store.
Sure.
And they asked, how long does it take to approve increased storage?
Okay. I would say probably a couple of days. Typically, if you talk to us directly in Intercom, we can start that process right away, and you can start putting your data in. It's easier if you're working on an NSF-supported project. Typically, we can approve those in just a day or so.
Okay.
Again, assuming it's during the work week.
All right. And then somebody asked about whether, and I think they were referring to your whole use of VICE, et cetera, whether that's available via an iPad app, via Juno Connect.
Interesting. So it runs in a browser. So I would assume that you could open Safari or Chrome on your iPad, and you could log into CyVerse, and then you could start your app. So as long as you have internet connection and a browser, you should be able to run that. If you wanted to run it as an app on an iPad, that's a little different. But I think that's, and I'm not familiar with the Juno Connect.
Okay. Somebody asked, what happens when HPC jobs fail? How is the recovery done?
Sure. So when you run a non-interactive app in the discovery environment, you'll see logs which are generated. So let's presume that the job fails completely, then you wouldn't have any output data to worry about. But you could view the log and you would see what failed, if there was a incorrect flag or an incorrect field set. If your job ran 50% of the way, you would be able to see that it got most of the way done. You have an option to relaunch those jobs. Depending on what it is that you're doing, I don't know if we'd have a way to restart the job at the midpoint of where it failed, but we could talk with our core software folks about that.
So the follow-up question on that was, what happens when there's partially processed data? Do we have access, or do we just get a data dump?
Yeah, if the data are partially processed and they can't be restarted from that point, then it would just be a data dump. The data should go into your analyses folder, which you can then access. If the data are partly complete and they can be restarted from a midpoint, then you would have that access.
Okay. I think this question refers to the data storage, but it might be a generic question about just using CyVerse in general.
Sure.
What if you do not have any NSF funding? Can you still use but have to pay? Maybe
No,
that's
you can
regarding the data.
use CyVerse. So CyVerse is free to everyone to use. The folks that need to pay to use CyVerse are the people that are using exceptionally large amounts of the platform. So if you have more than 10 terabytes of data that you need us to host for you, you can't just keep those on another service. So part of the benefit of VICE is that it's on internet too. If you have data that are hosted somewhere else, you can bring those data into the analysis platform. You don't have to have us hold them for you. If you are an international community member, there are some limitations to using CyVerse. We're a US-based project, and so you would have to talk to us probably offline about that.
Okay, thanks. Where is the recipe for Docker? Can you provide a link?
Sure. So our Docker recipe files are all in our CyVerse VICE organization on GitHub, and one of us can probably provide that. I'll go ahead and type it in now. So there are multiple CyVerse organizations on GitHub. There's the CyVerse.com or the CyVerse organization, which is our official. And then there's CyVerse VICE, which I've just put in there. And that's the one where these interactive VICE apps are available.
Okay. Jupyter Notebooks seems to be working okay, but how about our dependencies?
Yeah, so we use the Rocker project containers. And so as long as your application runs with our packages, it should run right out of the box. If there are other Linux dependencies, so for example, I work with geospatial software. A lot of geospatial dependencies are written in other languages than R that R calls upon. So I have to install those into the Linux kernel. And so if I have a software which is not yet installed that runs in Linux and not in R, I have to add that to the Docker file and build it before I launch it in Vice. And so we have a workflow for running your container locally, so you can test it locally and run it locally before you integrate it onto CyVerse. Further, all of the containers which are in the CyVerse VICE organization can be run on your local machine. So you don't have to run them in CyVerse. You can take a container and run it right now if you have Docker installed.
Okay, that seems to address the next question, which is, can the data directory be on a local computer?
Yes, so you can bring your CyVerse data stored data onto your local computer. So if you want to download data to your laptop or to your workstation, you can absolutely do that.
Okay. What access level do we need so as to ensure it is reproducible and can be used interactively on data at our personal data?
I think I need to see that question again.
That's at 1127 from GSCF. Can you see that one?
Yeah. Okay. So, what access level do I ensure the data are reproducible? So, the access becomes shared. So we have two different sets of sharing. There is let's see, it's a CyVerse user share. So that means that you can share those files with everyone with a CyVerse user account. And then there's anonymous share, which means that you're sharing those openly on the internet. So when it comes time to publish your research, if you want to host your data in CyVerse, it could be your data, it could be your notebooks, you can change the privileges on those folders to be shared with public, which is the CyVerse, or with anonymous, which is the internet. And you can move those either from your personal CyVerse user account space to a community folder, which is then available to everyone. And so that would help with the interactivity. So the interactive part is whether or not you want to put your Docker files on the Docker Hub, and if you want to make those public with everyone.
Okay, thanks. There's another question. Is the point of departure only from the GitHub CyVerse site, or we need to use QGIS for geolocation?
Sure.
Is that ready to run?
So the QGIS app, I'll have to see if I've published the XPRA container. So I have that actually in my personal GitHub repository right now. So I can share that with everyone in a second if I type it in. But the public tool, I would need to publish that on the Discovery environment, and then everyone would have access to it.
Okay, thanks. And I think this is the final question. Why do we need to configure app in addition to the Docker Hub configuration?
Yeah, so you often don't have to. So if the app has all of the right configs, it could run directly in CyVerse VICE without any changes. Part of the issue is that by running this remotely on our system, which I didn't mention it, but we're using Kubernetes to start these jobs, there are some things that Kubernetes doesn't always like about the Docker file working directory, the entry point. And so if those aren't correct, including things like the ports, then the app may not run straight out of the box. So that's where you would need to make some config changes in your tool when you build it. And part of what Intercom is there for is that if you have any problems, you can ask us and we can take a look at those and we can help you get it fully integrated.
Okay, all right. That's it for now. I'm going to capture the chat this time and include that up on our documentation for this webinar, since there's some nice community suggestions here in the question and answer. Are there any final questions for Tyson before we end this. Okay, I don't see any. So Tyson, thanks so much. And again, please join us for our Spring 2020 series, which will commence on the 31st of January. We're scheduling the series now, and topics will range from chip-seq analysis to MakeFlow, a workflow app, and to several image analysis informatics projects that we'll profile. So thank you everyone for having attended today's webinar, and we'll see you in 2020. Happy holidays.
Okay,
Thanks,
bye
Tyson.
everybody. Thanks for attending. And I've given my email in the chat, and so I'd love to follow up with anyone with more questions. And let's get your tools and your apps built in CyVerse.
The final question is about video on YouTube. Yes, we do post our videos on our YouTube channel. So search for CyVerse and you'll see all the webinars there, including some basic ones that we call Get Started with CyVerse that Jason Williams, our lead trainer, does. So that's a great entry point for people who are unfamiliar with some of how CyVerse works. All right, thanks Tyson, thanks everyone.
Bye everyone.